YouTubers, welcome to part 2 of Fancy a Beer. If you've landed here for the first time, there's an intro and part 1 videos to this series. Please check them out first. Part 2 is going to be a bit longer, so please stick with me. Today I'm going to look at the wiring diagram for the project, the initial setup of the SFR-1, a working test model minus lighting, and installation of the software on Windows 10 or 11. I will at times refer to the manual by page number, and it would help if you have a copy open to look at as we go along. That way you can fully grasp what I'm talking about. Let's start with the wiring diagram, which is on page 9. Must we, I hear you say? Well, yes. Rest assured, I'm not going to talk about Ohm's law, impedance or voltage drop, but offer a structured look at how this lot all connects together to do the job that it does. The manual, pages 10 to 15, covers all of the following in more detail. And as with most wiring diagrams, it may look complex, but it isn't really. I'm going to break it down for you. The following areas aren't in any real order of importance, except to say when you do come to start wiring up, don't connect any power to the unit until you are confident of all of your wiring, have checked all necessary polarities and are ready to start setup. Remember, battery connects last of all. Okay, take a deep breath. Number 1, the battery and motor connections. Straightforward stuff. The battery wires terminate in a plug which can only be connected one way. Use a XT60 to Dean's adapter cable to connect to an NIMH or LiPo. Note the supply input voltage can be between 6 and 18 volts DC. A 7.2 volt battery works just fine with the module. You can tell the software what type of battery you are using, and we'll talk more about that later. You'll notice the motor cables off the SFR are yellow, positive, and blue, negative. You will most likely need to chop off connectors to join the SFR-1 to a motor. Most motor cables are red positive and black negative and need to be matched up accordingly. I use the brass core with a cut off the outer insulation part of a 5 amp electrical strip connector to connect them together. Each cable can be screwed into the block firmly and acts as a link for motor change if necessary. Use a large heat shrink cover or bind well in insulation tape to avoid a short circuit. Beats soldering a heavy cable, I can tell you. Number 2, servo connections. Note there are 3 servo outputs marked 1, 2 and L on the circuit board. Servos 1 and 2 are yours to assign. These might be gears, fifth wheel or something else. The third one, connected to L on the board, must be for the steering servo. Number 3, proportional channels. There are 3 distinct areas on the board for proportional channel connection. Those marked prop 3 to 6 on connector X2 are yours to assign. The motor control or throttle is prop 1 and the steering is prop 2. These 2, you'll note, are hardwired on the right hand side of the board. Number 4, speaker and volume control. The speaker connects to X7 on the board and the volume control to X8. If you leave the volume control off the SFR-1, it will output at full volume. So either fit a control so you can control the volume and mount it somewhere accessible on the truck, or use a spare channel if you have one and assign it to a rotary knob on your transmitter. Number 5, outputs. Connection of your LEDs is to either or both connectors X3 and X4. I will cover this off in more detail in part 3. Just one thing to note here, outputs on negative switching, meaning the load, the lead, is on the negative and the positive is common to all LEDs. Note the common red rails. Confused? Don't be. All will be revealed later. Number 6, standby switch. This is a small, low current miniature switch which you can mount somewhere discreet on your model. It isn't the same as disconnecting the battery. For example, when leaving for more than 24 hours or so, it's always best to disconnect the battery. This switch puts the SFR-1 module into a kind of sleep mode. Current draw is minimalised, so it saves your battery drain when using the model periodically, for example at a driving meet. You don't have to fit one, but I recommend you do. Number 7, receiver. Your receiver will need to be mounted reasonably close to the SFR-1 so the patch leads reach, obviously. Power for the receiver is provided by the SFR-1 through the patch cables. It's worth noting what is said on page 12, and I'm quoting this: the channel numbers of the SFR-1 have nothing to do with the channel numbers of your receiver. You do not have to connect channel 1 of the receiver with channel 1 of the SFR-1. If the joystick to accelerate your model is, for example, at channel 3 on the receiver, you have to connect channel 3 of the receiver with channel 1 of the SFR-1. Number 8, infrared transmitting diode. This is for wireless control of your trailer lights if you're going to use the LMIR16-4 module. The transmitting diode is connected to X5I, not to be confused with X51. Note this is also the port used for Bluetooth control, so you can only have one of these connected at any one time. See the connections table on page 8. Number 9, micro SD card. The SFR-1 comes complete with an installed micro SD card. It uses this to store your configuration. This is at X10 in the wiring diagram. Any changes you wish to make to the truck's configuration will require you to remove the card and put it in a PC reader device, communicate with the Sound Teacher software, save and then replace it back in the truck. Quite a process. Better to use the USB module. Talking of which, number 10, the K-USB-2 data cable. Connect this to X11 if you have bought one. The other end you can mount somewhere out of sight on your model, but consider the need to plug a USB cable into it. Once fitted, any programming is so much easier. No need to remove the SD card or lift the cab. You just hook up to Sound Teacher via the USB cable and make whatever changes. Send them down the line to the SFR-1 and that's it. Disconnect. Additionally, the cable allows you to see real time how your channels are behaving via the Start Diagnosis button. If you want to see some information on that, have a look in the manual, page 93. Number 11, initial setup, or teaching function as Beier call it. The initial setup push button and location of the 3 LEDs is shown in this graphic. The LEDs are red, green and blue and are part of the setup. So this is a good point to move on to the initial setup. Now this must be done on first electrical startup. It synchronises the radio with the SFR-1 unit, and page 16 of the manual gives you more information. Make sure all of your radio sticks and switches are in their neutral position. If you don't, your sticks may not work afterwards as you expect. The motor isn't used for this initial setup and won't run until the setup is complete and the SFR-1 has reset. Note the throttle control using a Beier system is different to the MFC. From centre position of stick, up movement controls the motor forward or reverse, and down movement from the centre position is a brake and emergency stop. Motor direction is controlled separately, and more on that later. So there are two ways to start setup: via the setup push button on the SFR-1 and using the data cable with a Sound Teacher software function called Start Setup. Quite honestly, the easiest way is to use a small plastic screwdriver from a Tamiya kit and press the board button. Now the following graphics illustrate the initial setup process for you. Make sure all of your channels are connected between the receiver and the SFR-1. Note on the diagram there the position of where the setup button is and where the warning LEDs are. 2. All channels are in neutral position. 3. Press the setup button on the SFR-1. Only for a second. A green LED flashes fast and the blue LED flashes once. If you get a red flashing LED, the unit is not receiving a signal from your receiver. Check your wiring and start the process again. 5. Press your throttle stick, which is usually the left one, fully forward for a couple of seconds and then return it to neutral. The blue LED should now flash twice and then go steady on. 7. Within 10 seconds, move your throttle stick backwards to its full position and then allow it to centre. The blue LED now flashes 3 times and the green LED light comes on steady. And that's it. If it hasn't worked, don't worry, just start that 8-step process over again. So next up is a video of a working test model, minus all LED connections. At this stage I only want to test all of the physical things, e.g. steering gears. This is for a wrecker truck, so in addition to the Beier parts we also have the Tamiya ACU02 actuator control unit wired in. Obviously this part is not required on models without a lift motor. So let's have a look at how all of the various parts come together. So we've looked at the parts, let's have a demo. I've already done the initial setup of the SFR-1 and set a few parameters in the software to give you this demo. I'll cover off the software in part 4. Let's get it fired up. As always, transmitter on first, then connect the battery, which will turn on the SFR-1. Transmitter's on, connect up the battery. There's a standby switch here, which at the moment is in the off position, which is why there's no lights on anywhere here. As soon as I switch this on, power will go to the SFR-1 and to the Spectrum receiver here, and it'll start running its startup sequence. So we're switching that on now. Lights have come on, that's come on, I'll just turn the volume down so that you can hear me. It's still running in the background. First thing you heard then at the start was a script or a macro which was written by me. You probably heard the driver walk to the truck, open the door, the interior light would come on but the lights aren't connected yet. The door shuts, the engine starts, it's followed by a short rev to build up air, back to tick over, and the interior light goes off. All of that done right at startup without touching anything on the transmitter. Can an MFC do that? No way. Let's test a few things. First off, the steering. Steering's on the right hand stick. You can see the wheels move on the truck. I'm not going to move them too far because with the axle stand here it does catch on the front steering mechanism. Let's try the throttle now, shall we? Now with the Beier system, the throttle is up and the brake and emergency stop is back. I have a switch here which is 3 position, which is engine revving, cruise control and normal running. Let's start with engine revving. I'll turn the volume up a bit so you can hear it. Now we're going to put it in normal driving mode. Watch the wheels. Moves forward and stops. If you're running at quite a speed, you can of course use the brake function, and when you use the brake function it does put the brake lights on at the back of the vehicle. If you pull it straight to the bottom you get what they call an emergency stop function, which just stops the truck dead. It's something the MFC doesn't do. Cruise control. On this, there we go. On this particular truck, I mean, look at that for cruise control. It'll do that in forward or reverse. We're in second gear at the moment. On the subject of gears, they're controlled by this switch here. I beg your pardon, we're in first gear at the moment. You might hear it change to second. Wheels have gone a little bit faster. And third gear. Second gear. First gear. Put it back into normal driving mode again. As soon as I let go of the throttle, you can see it stops. We have a horn. We put loads of things on here. This is all I've put on at the moment. Change of direction is stick down for 3 seconds. You can hear the sound. That will put on hazard flashes if you want them, and reversing lights. Now the vehicle will work in reverse. On normal throttle at the moment. Cruise is very useful in reverse. Just get the vehicle running very slowly in reverse. And you can concentrate on your steering whilst the vehicle is reversing. Brake it to a halt. Stop it. Didn't quite hold that stick long enough the first time to stop it. There is a throttle profile that I put on this truck which you don't have to use, and if you're not sure what one of those is, it effectively allows you to desensitize the throttle movement, whereas In some cases you can only just touch the throttle and the vehicle starts to move rapidly. The way I've got it set is it's like a logarithmic scale. You have to move the stick about a third of the way before it starts to do anything, and likewise on the braking. It gives you much smoother control of the vehicle. Try doing that with an MFC. Boom control. The boom goes up and down. Boom's going up. Boom's going down. When the model's completed, it will have, let me just turn the volume down a bit. When the model's completed, it will have these limiter switches fitted, one down here and one up here, which restrict the up and down movement of the boom. That's why I'm not moving it too far at the moment, because if you run it to the ends, top and bottom, it can jam in position. But I will show you that they're working. So that's the upper one. So when that kicks in, it'll stop it. And if we use the other one, that's the lower one. And stop. You've also got the manual control switch, which will be fitted just inside the cab at the back here, just inside the side of the truck rather. This one's a spring-loaded switch and works in exactly the same way as the transmitter does. So you've got the choice of both. And that's it. That's where all your lighting will go, into these two plugs here. But that won't be done until it's actually mounted on the vehicle. But this particular stage now, I'm quite happy that the configuration of that is good enough for that to be dismantled and put in place on there. The tip for you, you've probably noticed I've done here, is I just use a simple little bit of self-adhesive paper, and I mark each of the connection leads so that when I pull them apart, it's a doddle to put it all back together again. And of course you can pull these off once it's connected on the truck itself. This you saw earlier, which is the USB connection to the PC. You can get diagnostics whilst the vehicle's running at the moment. It doesn't even need to be connected to make it work at the moment, but I highly recommend that rather than taking the SD card in and out every time you want to change a program or something like that. That's it. Hope you enjoyed that. Last part of the video, installing the software on Windows 10 11. For this demo I'm installing the software on a machine running Windows 10, but the installation is exactly the same for Windows 11. Insert the USB. If it doesn't auto-run like the DVD, open Windows Explorer and navigate to the file called SFR-installer.exe and double click this file. You may get a UAC window come up, user acceptance control. Just answer yes to that. The installer window now opens with 6 buttons in German. In order they are SFR Sound Teacher install, the KUSB data cable driver install, Audacity install, Adobe Reader install, and YouTube to MP3 converter install, and the last button at the bottom is exit. Click on Install Sound Teacher, the first button, and follow the wizard defaults. On the last screen, remove the tick. It says Launch SFR-1 Sound Teacher, and click the Finish button. This will take you back to the installation screen. Repeat the install process for the second item, the USB driver, if you intend to use the KUSB2 data cable. If not, you can ignore the driver install. Install Audacity if you want to. It's optional. This is a great sound file editor should you wish to create or modify any sound files. Install Adobe Reader and the free YouTube to MP3 converter if you need them also. They are optional. Please note, none of the optional software items are needed for Sound Teacher to work. Exit the installation screen, which is the last button. Now run up Sound Teacher software from the Start menu or desktop icon. Chances are it will kick up a message saying the firmware is out of date. It is important we use the latest firmware as provided by the manufacturer. In order to do this, you need to quit Sound Teacher and open it again with administrator rights. It won't let you update without doing this. From the Start menu, right-click Sound Teacher and select the option to run as administrator. The program opens and the message reappears. This time follow the procedure to upgrade the firmware to the latest. As of this video's production date, it is version 1.30C. Allow the process to complete and install the latest firmware. When done, you'll see confirmation of firmware version at the top of the Sound Teacher window. There is a considerable number of sound files on the USB stick. These are contained in the folders called SFR-1 Sounds and Sounds. SFR-1 Sounds is the main folder with configuration files for trucks, ships and tanks. You'll need a starting point from one of these, more later on that. The folder called Sounds has all sorts of additional sounds. Have a look through them. You can copy these two folders to your computer if you like, or use the USB stick to access them. Personally, I find it more convenient for them to be on my computer, but note, there is a lot and it may take a while to copy them all across. Well, I'm sure you'll agree, we've covered a lot of ground there, and I hope I've done a good job in explaining things. Aside from the lighting, you should now have all you need to fit one of these devices. In part 3 we'll look at LEDs and lighting generally. So that's it for now. Hope you've enjoyed the series so far. Don't forget to like and subscribe. Bye for now.